So today I am going to talk about or to derive velocity in terms of spherical polar coordinates. So first of all, let me define uh, a radial vector, and after that, using that radial vector, I will derive the expression for velocity in terms of spherical polar coordinates. So yeah, so let us start it. So as we know that this r vector is defined as r cap, as we have derived in case of polar coordinates. So from here, if I take derivative of r vector with respect to time, then it is the velocity. And say this r vector basically contains two things: one is the magnitude and another is the unit vector, and both are changing with time. Both are changing with time. So therefore I can take its derivative r into r cap. So this is first function, this is second function, and both are changing with time. So that means we have to first of all take the derivative of r with respect to time and multiply with it the unit vector r cap, plus again r as it is in the derivative of the second function, and it is r cap, right? So as we know that dr by dt is represented by r dot, and r cap will remain as it is, plus r and dr cap by dt. Now this quantity is unknown to us. So let us first of all try to find out this quantity. So for this, let us proceed as follows. So what is it? Let me write down dr cap over dt, because this quantity must be unknown to me. So let us try to find out it. So d upon dt, and as we know that r cap is equal to sine theta cos phi I cap plus sine theta sine phi, and the j cap plus cos of theta k cap. So let me write down its value. So it is sine theta cos phi I cap plus sine theta sine phi j cap plus cos of theta k cap. As we know that this I cap and the j cap and the k cap, they do not change. They remain fixed. So let us try to find out its derivative. So what do we do to find out its derivative? Let us proceed as follows. So that means, let us try to first of all find out this part. So it is d upon dt sine theta cos phi, and I cap will remain as it is, plus d upon dt sine theta sine phi, and j cap will remain as it is, plus d upon dt, it is cos of theta k cap, right? So what is the derivative of this? This can be written as, this part is can be written as derivative of sine theta and cos of phi will remain as it is, plus sine theta as it is, and the derivative of cos phi, right? And both are having I cap. This is the first part, and similarly I will try to look at this part also. So this one, so it is again derivative of this sine theta and sine phi will remain as it is, plus it is sine of theta and d of dt of sine of phi, and whole contains j cap plus d upon dt of cos of theta, and it is a k cap. So what is the derivative of sine? The derivative of sine is cos of theta, and I will apply a chain rule. It means I have to take again the derivative of d theta by dt, and then cos phi will remain as it is, plus sine theta. The derivative of cos phi will be minus sine phi, and again derivative of phi with respect to applying chain rule here, d phi upon dt, and whole I cap plus here the derivative of sine theta will be equal to cos of theta and d theta upon dt, and sine phi will remain as it is, plus sine theta, and the derivative of sine phi will be cos of phi. So this derivative will be it is cos phi, and the d phi over dt will remain as it is, and whole will remain as a j cap plus cos of theta. Derivative of cos theta will be minus sine theta, and again d theta upon dt, it's a k cap, right? That's what they're with us. So let me, so this is cos of theta, theta dot cos of phi plus, it is plus minus 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 sine theta, sine phi, and phi cap, and I cap is sitting here, so it can be placed with it and it also, so it is I cap and I cap, then plus cos of theta, theta dot sine phi, j cap plus sine theta, cos of phi, phi dot j cap minus sine theta, theta dot k cap. So so let us take theta terms. Theta dot is sitting with this also, and theta dot is sitting with this also, and here it is it is theta dot is sitting here. So theta dot is sitting with this term, and this term. So let us take theta dot common here, and inside it is cos of theta, cos of phi I cap plus cos of theta, cos of theta, sine of phi minus sine of theta. This is it, and it is I cap, and the j cap is sitting with it, and say just a minute, it is j cap is sitting with it and k cap is sitting with it, right? So now let us try to look at, say, if now I try to look at this part, this term, this is one term and this is another term. If I try to look at it, so sine theta is sitting with both, and phi cap is also sitting, sine theta and the phi cap. So that means if I take, if I write down plus, so it is phi dot sine of theta, inside it will be minus sine theta, no, minus sine phi, and here it is plus cos phi is sitting with it, and I cap is sitting with it, and the j cap is sitting with it, right? And if I recall earlier results, then this particular quantity is equal to, this is equal to theta cap, and this particular quantity is phi cap. So therefore I should write down it as, therefore dr cap over dt, it can be written as theta dot theta cap plus phi dot sine of theta, and is a phi cap, right? So let me put this value. Yeah, so that means I have defined V as r dot r cap plus r into dr cap over dt, and this is the value of this. So let me put this value here. So it is r dot r cap plus r, inside it is theta dot theta cap plus phi dot sine theta and the phi cap. So this can be written as r dot r cap plus r theta dot theta cap plus r sine theta phi dot and the phi cap. So here this can be written as Vr vector plus V theta vector plus V phi vector, or this is simply written as, here what is Vr, means one is the ready, so that means I can write down these components as like this. So that means this Vr is equal to here r dot, and Vr vector is equal to r dot r cap. Similarly V theta can be written as r theta dot, and V theta vector is basically r theta dot theta cap. Similarly V phi is r sine theta phi dot, and V phi vector, it can be written as r sine theta it is phi dot and phi cap. So these are the various components of velocity in terms of spherical polar coordinates. So that's all for this lecture.